polynomial. So what this is a function. So let's say a polynomial function is defined as, we'll use p of x. I mean, I could use f of x, but p for polynomial. P of x is a sub n x to the nth power plus a sub n minus 1 x to the n minus 1 power. So this is just saying the next lowest. So like if this is to the 4th power, this one would be to the 4 minus 1/3 power, and keep going until we get to a sub 1 x to the 1 plus a sub 0 constant. So whatever this power is, just written in descending order. So if we write it like this, the a sub n's, a sub n minus 1, all the way down to a sub 1, a sub 0, these are all real numbers. So they're the coefficients, real numbers. And then the exponents, the n's, the exponents need to be whole numbers. And remember, whole numbers, this would be like 0, 1, 2, 3, and so forth, starting at 0. So whole numbers, no negatives. So out of this too, I want to point out that the first, right now here I have this in descending order. The first term, a sub n, x sub n, this whole thing is called the leading term. And a sub n by itself is called the leading coefficient. And then n is the degree of the polynomial. So whatever the highest exponent is, that is called the degree. Okay, so there's some definitions to start off with. Let's look at some examples of polynomials and pick out some of these definitions. So let's say we've got f of x is 2x cubed minus 4x squared plus x minus 1. Okay, so here's our function. Let's make a couple columns here. So let's pick out what the leading term is, the leading coefficient, the degree, and then we're going to have special names for a lot of these too. Okay, so the leading term would be this whole first term. It's in descending order, so we look at the highest. The leading term would be 2x cubed. The leading coefficient is just 2, the number in front, the coefficient, and then the degree would be 3. And anything that has a degree of 3 is called a cubic function. So this is cubic. Maybe we'll label these. That was A, B. So how about the next one? How about x squared minus 4x to the 4th plus 3x cubed plus 2. Okay, so notice right now it's not in descending order. So we need to pick out what is the highest exponent, 4. So the leading term is actually negative 4x to the 4th. And I am going to note that this is negative. This goes with that term, because that's going to make a difference in terms of if you have to graph this or things like that. So then the leading coefficient is negative 4. And then the degree is this 4 for the exponent. And things that are degree 4 are called quartic. Q-U-A-R-T-I-C, since I wrote that a little squished. Okay, so anything degree 4 is quartic. How about f of x equals 6? That's it. Just f of x equals 6. And, think about it. Remember, f of x is just like y. Y equals 6. So the leading term is 6. The leading coefficient is 6. How about the degree, though? Because if there's nothing there, this is the same as x to the 0 power. 6x to the 0 power. Because anything to the 0 power is 1, which means that would just be 6. So the degree of a constant term is 1. And this is called, well, I just gave it to you, constant polynomial. Okay, and remember that would be, if we were to graph this, that would be a straight line at 6, up here at 6, constant function. Okay, how about f of x equals 3x plus 5? That's in descending order. First term, 3x, leading term, leading coefficient's 3. Degree is, I mean, we don't see the exponent, but that's like a 1 right there. So the degree is 1. And this would be what type of function? Like a linear function. And then let's do one more. So the one we're missing, let's see, we had degrees 0, 1, so I'm going to throw in one that's squared. How about x squared minus 4? So leading term, x squared, leading coefficient is 1x squared, and then the degree would be 2, and this would be quadratic. Okay, so we went for degree 0 to 4. If we went up to 5, there's not really a special name for it, at least not commonly used. So we would just say degree 5, degree 6, so forth. Okay, so one last thing. So these are a bunch of polynomials, and let's think about what are not polynomials, just to kind of compare. So notice the thing about polynomials, the main idea, hopefully you picked up from that, is that they are have whole number exponents. So things that would not be polynomials would be things like f of x is 1 over x, which is a rational function. But think about it, you could rewrite this. This is x to the negative 1 power. So it's not a whole number exponent, and it's not going to behave the same as a polynomial function. Or how about f of x is the square root of x? Okay, again, it's not going to behave like a polynomial function if it's a radical function. This is the same as x to the 1/2, right? So not a whole number, again. Even though it's positive, not a whole number. So those are two examples of non-polynomial functions. There's others, you know, like exponential, if you have, maybe you haven't seen this yet, but something like f of x is 2 to the x power, or logarithmic, log x, or lots of other things that it could be, trigonometric, things like that. But here's some of the common ones that are not considered polynomial because they don't have whole number exponents.